Hello, everyone. Today I'm going to talk about what we did to improve and streamline the Highway Safety Improvement Program in Texas, the HSIP or HSIP, however you want to call it. Before I start the presentation, I would like to thank a lot of people, the TxDOT panel. We had a very good representation from TxDOT districts that provided feedback throughout the process. Ismael Soto, he is not with TxDOT anymore, but he had a lot of nice ideas that we tried to address in this project. And of course, my colleagues at TTI, Karen Dixon was the co-PI, and she provided valuable feedback throughout the process, and a bunch of smart people that without them, I wouldn't be here today. And Bahar is actually one of them who's going to present her analysis. Like any presentation, I'm going to talk about the goals and objectives, the framework that we used, and based on that framework, we performed the study. The framework includes 6 processes that are included in the Highway Safety Manual, and we addressed 4 of them, or at least we try to improve 4 of them that you can see there. And at the end, I'm going to talk about benefits and recommendations. So the main questions that we try to address, the first one is the multi-million-dollar question that a lot of state and local agencies have been trying to address, is how can TxDOT invest HSIP funds so as to get the biggest bang for the buck? There is not a single straightforward answer to this question, but there is a lot of little and bigger things that you can do to at least go to and move to the right direction. The second question is how to create a level playing field for the districts that participate in the HSIP. Some districts were able to develop specific products and others did not. So as you will see, we developed specific products that were disseminated to all 25 districts. So partially we were able to address this question. And also the last question is how to improve and streamline existing HSIP processes so TxDOT can save time and cost. So this is the framework that I was talking about. This is the roadway safety management process that is included in the Highway Safety Manual. It includes 6 sub-processes, starting with network screening. Network screening is a data-driven process. So the goal there is to identify and rank sites from most likely to least likely to realize a reduction in the number and severity of crashes through the implementation of HSIP projects. After you perform network screening and you identify your hotspots, then you move to the second step where you try to better understand crash patterns and trends and the contributing factors for each crash. And after you do that, then you're in a better position to go to the third step and select appropriate countermeasures so as to address the safety needs that you identified in the second step. After you come up with a list of candidate projects, you compare benefits versus cost, you do an economic appraisal, and then you get that list and you apply specific project prioritization methods to essentially fund specific projects. Obviously, you cannot fund all of them. After you fund the projects are built, and perhaps some time has passed after construction, then you go back and you do an evaluation, and you try to find what worked, what didn't work, what were the effective countermeasures. So the lessons learned from that process feed the entire process. You go back to network screening and you make changes to the process based on the findings of the evaluation. So this is a cyclical process that needs to repeat itself once in a while. Given the time and the budget, of course, we were not able to address all these processes, but we try to focus on these 4 that are highlighted in these red rectangles. And that's what we're going to present today. If I were to put these processes next to each other and expand them and include some of the steps and the activities that are included in each process, you would get this level 2 diagram. So the first box is network screening. We further disaggregated network screening and we developed this diagram in order to essentially perform network screening using data in Texas. Then we developed an innovative crash analysis and visualization process. The idea behind that process came from Corpus. Ismail had that idea a few years ago, so we were able to build upon his idea and make some improvements. And this covers both the diagnosis and countermeasure selection processes. And the last process is the project prioritization, for which we developed a spreadsheet that incorporates some of the latest HSM methods. Let's move with network screening. Some of you might have already read the HSM and you are familiar with network screening. In case you don't, here's the concept, and I'm going to present that. I think that will be easier for everybody to understand. Let's assume that we have this sample network. The goal is to come up with projects. So what do you do to come up with projects? The first thing you can do is to apply a data-driven process that accounts for the crashes on the network, and the crashes in this case are the red dots. So you focus on every link individually, in that case, that blue link, and you create windows of specific length. In that case, I selected a length of 0.2 miles. Then you move the window at increments of specific size, which again, in this size, we selected 0.1 miles. So how it works, you calculate a series of performance measures, crash frequency, crash rate, and other more advanced performance measures for that starting point, for that window. And after you calculate the performance measures, you move the window at 0.1 mile down the road, and you recalculate these performance measures. And you repeat this process by moving the window, calculating the performance measures, until the window reaches the end of the segment. After you're done with segment AB, then you move to the next segment, and so on and so forth. So at the end of the day, when you perform network screening in Texas in the entire network, you ended up having thousands of windows, and for every window, you have these 7 performance measures estimated. This table shows all 13 measures that are included in the Highway Safety Manual, but given the data availability at TxDOT, you cannot calculate all of them. So we did an evaluation, and we found that you can calculate these 7. And at the end of the day, of course, we calculated an average weighted performance measure to account for all the performance measures listed here. Now, that was the theoretical concept. To make this thing work, we had to develop tools. So we developed this GIS toolbox that contains a series of models and scripts. So I'm going to show you one model here. After we run the model using TxDOT data, Rhino, Crash, and some other data sets, we move to the second one, and then to the third one, until we reach the end of the last model in the toolbox. So when you do that, the output is this one. Here you can see the very high-risk segments and the high-risk segments. And as part of the 2018 and 2019 HSIPs, all TxDOT districts will receive the results of network screening through an implementation project. That was network screening for segments. You have to apply a different approach, network screening approach, for intersections. You all know that there's not a comprehensive intersection database in Texas, so we were not able to do it statewide, but we did a demonstration using data from San Antonio, and Bahar will present this analysis.
So to do the intersection network screening, it's a little different than the network screening for the segments. It's actually based on the simple ranking method rather than sliding window. So we had 264 segments from San Antonio. Actually, Jingli also helped me with that. We had to collect data from several sources, and so we had to use a CRIS database to get the crash data for the intersection. For this one, we applied a buffer of 250 feet, yeah, around all of the intersections to select the crashes that were intersection-related crashes. We used the Rhino data to get information about the segments, the intersecting segments. We had to get data for all 3 or 4 legs of the, and then to get the, Rhino does not provide all the information about the segments, like traffic control type or the number of the lanes. So we had to, like, type of the lane. So we had to do that manually. We had to collect data from Google Earth for that. And after collecting data, we did data integration using GIS. And as Ioannis said, we used 7 performance measures to do the ranking. As you can see, like the first one is average crash frequency, then crash rate, critical rate, the method of moments, which gives the potential for improvement, and then the screening performance measure that was based on the SPFs. So we had to look at this, calculate the SPFs also for these intersections, and the probability of exceeding this threshold measure. And as you can see, like those are the numbers of the intersections. For example, intersection 20 was selected as the highest for potential, with highest potential for improvement by crash frequency and crash rate, as well as method of moments and the excess SPF. In order to identify which of these intersections were actually had the highest potential for improvement, we did a weighted average ranking, like Yanni mentioned. To do that, we had to look at the several strengths of these methods, and for example, if we had to see if the method was accounting for the regression to mean bias, or if it was accounting for traffic volume and or roadway design elements. As you can see, the first, for example, the crash frequency and crash rate is no, so it's like they do not account for many factors. That's why we had to give them low ranks, like the low weights, while we had to give a higher weights to the one that was based on the SPFs. So after that, we did the ranking of the sites. For example, you can see that in certain locations we have the intersections that had the highest potential for to be selected. So that was the network screening for the intersections.
Thank you, Bahar. So hopefully in the future, if there is a statewide intersection database, we would be able to perform this analysis everywhere in Texas. The other component that we developed was the crash analysis and visualization process. Over time, we ended up developing two different tools to develop a series of products that you will see in the next few slides. The first one is ArcGIS based, and you can see them at the bottom left. And the other one, which was developed as part of a different project, but it creates the same products as the first one, is a Windows application that we use to select our countermeasures, districts, and so on and so forth. So we were able, using this application, to develop thousands of layers in a matter of 2 minutes. So this is just a sample layer. It shows the crash locations where, in theory, somebody could install warning guide signs. The concept behind it is that these crashes could have been prevented, theoretically speaking, if warning guide signs were in place prior to the crash. And you can see some other layers listed there in the left column. During the process of selecting projects, you would turn on and off these layers, and depending on what you're looking for, then you would see what crashes qualify for what kind of countermeasure. If you were to click on any crash point, you would get the attribute table for that crash that contains a lot of variables. And if I were to scroll down, you would see other work codes that apply in that particular location, as well as traffic, roadway data, and some of these variables are useful for anybody who selects projects and tries to better understand the conditions behind the crash and how the location can be improved. Another concept that had been applied in Corpus, and we just adopted it in this project, was the master plans. Here what you see are segments color-coded, and the color depends on whether a project has been completed. That layer shows you the cable barrier projects. So in that case, you wouldn't really look for the green segments because you know that cable barriers exist there. Orange segments, which are not shown here, show projects that have been funded, but construction has not started yet. And the yellow segments show projects that have been identified and for which funding is needed. So by overlaying the KABC data and the master plans, you can make your life a little bit easier and just simply focus on the yellow segments instead of looking everywhere. And in that way, you can also start developing a project inventory. The third component was the project prioritization tool that I mentioned before. This is the spreadsheet, or part of the spreadsheet. It incorporates the IBCR method. It's the incremental benefit cost ratio method. So by simply copying, pasting project data, specifically the construction cost and the SII of each project, and by pressing the button, you get a new ranking based on that advanced method. We did an analysis and we compared the existing TxDOT approach, which relies heavily on the SII versus this approach, and the two complement each other very well. There is a very good matching. The most difficult question for researchers is the so what question. So the benefits gained from this process and the products are shown here, the main benefits, not the only ones. So we found that the number of projects submitted to the HSIP in 2017 versus 2013, when these products were not available, increased by 57%. It's important also because districts were able to identify more projects in less time. So according to their feedback, the time that they spent to identify projects reduced anywhere between 15 to 50%. And as I mentioned before, the project prioritization method complements the SII. Each method tends to favor different types of projects, so there is a very good variety of projects if you apply both of them. And TxDOT has been extremely proactive and responsive to embracing all these data-driven advanced safety assessment methods and tools, and they have taken huge steps towards the direction that the research community has been pushing all DOTs to go. And you can see here why. One of the recommendations was to implement network screening and the CABS process, and this is currently done through an implementation project that just started. In a new research project, we're going to evaluate completed projects and countermeasures throughout the state, and we're also going to develop tools that districts can use in the future to conduct independent project evaluations. Another recommendation was to develop an intersection inventory, and I do know that some of my folks, Karen, Edgar Krause, and some other people are working on that, and TxDOT is very interested in developing an intersection database because of the HSIP final rule and other relevant regulations, and also develop new SPFs. I know at least Karen is also working on 1 or 2 projects doing something like that, and I've heard that the Traffic Operations Division is very interested in developing new SPFs as well. So many kudos to TxDOT for actually doing a lot of things in a very short period of time. And thank you. If you have any questions, you can ask me or Karen.
Any questions from the audience? Yes, sir.
The benefit cost ratio is an important factor in deciding the countermeasures you are going to put at a certain intersection. But that benefit is based on the severity of crash, injury, all those. It's a dollar value to a human suffering. Sometimes all these insurance companies in different states keep changing rates, and that could sway an engineer to make a decision based on the dollar value only, but not the suffering of the individual. What are your thoughts?
That is
So
a very good.
let's repeat the question. The question is that the cost-benefit ratio, that a dollar value is assigned to a crash. So if there's a fatality or injury or property damage only, there's a value associated with that. However, there's a personal suffering that's attached to that crash, and that doesn't have an assigned dollar value. And that's the question. And what are your thoughts on that?
Very good point. And this concern or question has been shared in the research community. There are TRB committees and subcommittees that deal specifically with economic appraisals and exactly what you just said. To be more specific, though, up to 2016, I believe, as part of the 2016 HSIP, TxDOT used the economic cost in the SII. In 2017, they applied the comprehensive cost, and the comprehensive cost accounts for all these additional factors that typically you cannot directly see with the loss of a life. Insurance costs and you name it. So I don't think that there is an answer, the answer to that, but for sure there's a lot of different components that at least they are captured now through the comprehensive cost. Is it ideal? Probably not, but given that you have to be able to justify why you spend the money this way, this provides a data-driven approach and you can do that.